Hi folks, today we're going to talk about graphing lemniscates, and basically it's just another type of polar graph. You'll see that the equations are slightly different because in these equations we have r squared, and when you see r squared that tells you that it's going to be a lemniscate. And I'm going to go through two different examples, and really the only thing that's different is the trig function that is in them. And that's going to make the graphs look a tiny bit different. But let's go through how we would graph this, and let's go through how we can do that on the calculator. Again, what you want to do is you want to make sure when you press mode that you are in polar mode. So that's the fourth one down. You want to go over to where it says POL to make sure you're in polar mode. The next thing we want to do, as I said previously, is if you notice our graph, it goes up in increments of pi over 12, which means we want our table to go in those same increments. Okay, so if I do second window and I hit that brings me the table set menu, I want my table to start at 0, but I want it to go up in increments of pi over 12. So you can go ahead and put that in right here, pi divided by 12. And when you hit enter, it's going to change that into a decimal, but that's fine. Okay, it's going to make your table go up in increments of pi over 12. So what we can do, because we're in polar mode, our equations are going to be in the form of r equals, and so you'll see that on your calculator screen as well. The issue is that our equation is given to us as r squared. So when we put it in the calculator, we just have to take the square root of both sides. So when I put it in the calculator, I'm just going to hit second x squared to get me that square root function. And then I'll have 4 sine of 2 theta. Remember, theta is the same button as x when you're in polar mode. Make sure you close your parentheses. And now if I go ahead and hit second graph, that'll give me the table. And each of these values under theta is increments of pi over 12. So you'll see here we start at 0, 0. And then at pi over 12 we're at 1.4. So we're right about here. At 0.52, that's pi over 6. We're at about 1.8. Right about there. And then we're up here at 2. And then you'll see it kind of goes back down. Oops. So up there, and then 1.4. Like about there. And then back to 0. And then if I scroll down, I'll see I've got all these errors for those next ones. So let's see. These are in increments of pi over 12, right? So I was at pi over 2, and then the next one would be 7 pi over 12. Here's 8 pi, 9 pi, 10 pi, 11 pi. So if you think about this, right, this pi over 2 is this 1.5708. Right? So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the next 5 ones are errors. And then when I get to pi, I'm back at 0. Okay, so I know that when you look at these decimals, you're not seeing the same values as you have here, but know that these are going in increments of pi over 12, which are each one of these marks on our graph. Okay, so then I'm back at 0, and now I'm into the third quadrant. So in the third quadrant, I'm at 1.4, 1.8, 2, 1.8, 1.4, and back at 0. Okay, and then if we go into that next quadrant, we have all errors again. So in that second and fourth quadrant, we don't actually have any graph. And so what happens is we end up with what looks like this this kind of figure 8 kind of looking thing. It kind of looks like that, and it's kind of on a little tilt. And of course my graph didn't come out all that great, but it's supposed to be more rounded. And that's what your lemniscate looks like. It's like a figure 8, but because it's sine, it's kind of on that tilt, on that 45, as kind of or that pi over 4 is kind of that, cuts it in half. Okay, let's go ahead then and do the same with our cosine of 2 theta, or excuse me, r squared equals 4 cosine 2 theta. So let's go back, and this time we'll, instead of sine, we'll change it to cosine. Okay, and if I hit second graph, that will give me my table again. I can go back to the beginning here. And we were at 0. So at 0, I'm out here at 2. And then I'm down to 1.8. And then I'm down to 1.4. And then here I have errors. Error. And just in the interest of time, I'm going to kind of go through this same idea here. We know that it's going to have that same the same kind of shape as this one, and so I'm not going to count out all of those error kind of things, but you'll see what happens is this. We end up with our Lemniscate being symmetrical about that polar axis. Okay, so it's the same shape, it's just cut in half by that polar axis, where over here for sine it's cut in half by that pi over 4 axis. Okay, so same idea here. I'm just not going to go through, just in the interest of time, and counting out all of the ones that had error on it, but that's the idea of the shape of it. And you can graph it, and you'll see when you graph it, and it's kind of hard to see here, but you'll see that it goes right across. If you zoom in, if you hit zoom 2, you'll see that it kind of does that. And you'll see that my calculator is kind of limited in being able to fill that in, but that's the general shape of it. It's going to kind of look like this figure 8. Okay, so on the bottom of your notes, here's the idea. When it is given to you with sine in it, it's always going to be 2 theta, and it's always going to be r squared. That's how you'll know it's a Lemniscate. That value that's here is a squared. So in our case it was 4. That's why my graph only went out to 2. And I think I actually did it to 3. I miscounted. 1, 2. I made it a little bit bigger because I miscounted it. 1, 2, 3, just so you could see it. So I did go out farther than I should have on my graph. But I think you get the idea. So when it's sine, it's going to be, have this shape, and then this distance right there. That's your A value. Okay, and when it has cosine in it, it's going to be about that polar axis, and this distance right here is going to be your A value. So if this was, if it was r squared equals 25 cosine 2 theta, you know you're going to go out to 5. Okay, same idea here. If it was r squared equals 64 sine of 2 theta, you know your graph is going to go all the way out to 8, because you're going to take the square root of that number that's in front. That's pretty much it for Lemniscates. They're pretty straightforward. They're not too complicated to graph. Again, you're going to make sure that you have your calculator set up properly. Again, if you hit second window, you're going to change the table setup option. You'll start at 0, but for the delta table, or the change in table, you want it to go up by pi over 6. That way it matches the graphs here, and you can easily follow along as you go. All right, everybody, that's it. We'll see you next time. Thanks.